Using Newton's law of gravity, derive the equation to find the mass of the Sun. What is the mass of the Sun? The radial orbit of the Earth around the Sun is 1.5 times 10 to the 11 meters. Take G equals 6.674 times 10 to the minus 11 Newton meters squared per kilogram squared. So in this problem, we're assuming that the Earth travels around the Sun in a circular orbit. So that's our assumption. So here's our Sun, and here is the Earth, not drawn to scale. And when we assume that the Earth's mass compared to the Sun is negligible, the Sun's mass is much more larger than the Earth. We're told that R is equal to 1.5. The radius of the Earth orbit around the Sun is 11 meters, and we have to find the mass of the Sun. The mass of the Earth is negligible. We don't know what it is, but this is what we're trying to find, the mass of the Sun. So we know the force of gravity. If it's a circular orbit, we know the force of gravity is equal to G, the mass of the Sun, times the mass of the Earth over R squared, by using Newton's law of gravity. But if it's a circular orbit, there's only one gravitational force pulling on the object, so that must be equal to mv squared over r. But the velocity of the Earth, this is the Earth, is given by the circumference of the circle of the orbital radius, the circle of the orbit of the Earth, divided by t is the velocity, or the speed around which the Earth is traveling around the Sun, squared, all divisible by r. And so this is what we're looking for. So I'll write this equation again. Mass of the Sun, mass of the Earth, divisible by r squared, is equal to mass of the Earth times 2 pi r over t squared, all divisible by r. So we can cross out the mass of the Earth. It's negligible. So we move the r squared to this side and pull down the g. So we're left with that the mass of the Sun is given by 2 pi r over t squared times r squared, all divisible by g r. So this is going to be 4 pi squared r squared times r squared is r to the 4th, divided by r is r cubed, over t squared. There's a g coming down at the bottom. So we can plug in numbers for the calculation. So this is 4 times 3.1415926 for pi squared. The radius, the orbital radius is 1.5 times 10 to the 11 cubed. Gravitational constant is 6.674 times 10 to the minus 11. Time for a single orbit around the Earth going around the Sun is a year, so it's 365 days. Each day has 24 hours. Each 24 hours has 60 minutes. Each minute has 60 seconds, and that's squared. So we can plug it to our calculator. And find the answer for the mass of the Sun. 4 times 3.1415926 x squared times 1.5 exponent to the 11 xy cubed divisible by 6.674 exponent to 11 minus divisible by parentheses 365 times 24 times 60 times 60 close parentheses squared equals 2.0 times 10 to the 30 kilograms.